Today, Mathematics 227 Statistics. We learn Chapter 7, the confidence interval. Confidence interval. We talk about homework question, examples of Chapter 7 homework. So this is the formula we are going to use we are going to cover in Chapter 7. First is z-score or standard score. Z equals x minus population mean, minus mean over standard deviation. That's for the population. And the central limit theorem. Central limit theorem is use the sample mean. Sample mean minus population mean over the population standard deviation divided by square root of n. N is sample size. And this is for the sample mean, x bar. And for this one, if n equal 1, so n equal 1, which is just 1, n equal 1 is use this formula. If n is more than 1, you divide it by square root of n. And the mean and the standard deviation for the binomial distribution. Mean for the binomial distribution is n times p. Standard deviation is variance npq, take square root. And the confidence interval of the mean when the population standard deviation sigma is known, and use z-score. If a sigma known, use population standard deviation is known, use z-score. Z alpha over 2. And the sample mean, sample mean minus z times sigma over square root of n. There's confidence interval for the mean. And the sample size, this is E we call the margin error. I'll give you these examples for when we talk about examples. We will use this formula, find sample size. If the population standard deviation sigma is unknown, use t, distribution, t alpha over 2. If a sigma is known, and use z, z-score. This use unknown, use t-score. And the confidence interval for proportion, which is a sample proportion, p hat. Standard deviation is this one. We will talk about that later. And sample size for proportion formula, this. Confidence interval of the variance, use the chi-square distribution. Chi-square distribution. And the confidence interval for standard deviation is just variance, take square root. Sigma square takes square root is sigma, and this side takes square root, this side takes square root. And those formula, we will use the examples. Let's talk about first question. First question say an interval estimate must not contain the true value of the parameter being estimated. Circle your answer, true or false. This answer is false because the confidence interval to estimate the population parameter, for example, to estimate population parameter including population mean or population standard deviation or population variance or population proportion. Those are parameter. The confidence interval, the interval may probably contain the true value of population parameter, or may not contain either one. can contain or not contain. So if say must not contain, it's not true. It's a false. If I say must contain, question ask you, that's your homework. This is your homework question. If it must contain, the true value of the parameter is also false. So this answer is false. And put example, I put not, is also answer false. And because interval can contain or not contain the true value of the parameter. Question 2. In a recent study of 36 ninth grader, n equal 36, given n equals 36, and the mean number of hours per week that they play video games was 68 point, this is your homework, 0.8, that's your home hours. I changed it, 15.6 hours. Mean value, we total n is 36, students average, sample mean, x bar, sample size is 36, sample mean is average for 36 students is 15.6 hours to play the video games. The standard deviation of population, so population is a sigma equal 2.8 hours. I change it, 2.8 hours, 2.8 hours. Ask you, A, find the best point estimate of the population mean. The population mean, mu, the best estimate is the sample mean, x bar. So x bar is 15.6 hours is the best point estimate of the population mean. Sample mean is the best point estimate of the population mean. And the next one, B, find your homework is a 90% confidence interval. So I change it to a 95% confidence interval. Find out 95% confidence interval of the mean of the time playing of the population mean. The population mean of the time playing the video games. So we will use this formula. This is a formula. We are going to use this formula. Confidence interval, since population standard deviation sigma given 2.8, so use z-score. And the confidence interval is sample mean x bar, which is 15.6 minus z-score. I'll talk about z-score later. Then sigma given is 2.8 over square root of n given is 36. And less than population mean is between the two number. We call confidence interval. So, and the sample mean 15.6, that's the question given, plus, I'll talk about this later, z-score. And the standard deviation for population given is 2.8 over square root of n. N is 36 given. Sample size is 36. Now, then what is 1.96? How we get 1.96? And this 95% confidence, or question asks you 95% confidence interval. So you are going to look at the T distribution, this table. T distribution table. This is T distribution table. On the top, confidence interval, 80%, 90%, 95%, 98%, 99%. This is called confidence interval. Now you go to the bottom, go bottom. Here has Z is infinite. This side, degree of freedom. That's for the t distribution, degree of freedom until 1 through 1000 until Z score infinite. So from here, if a confidence interval asks you 80%, then the Z score on the bottom is 1.282. If a confidence interval asks for 90%, then the Z score on the bottom of this table is 1.645. Z score. And if confidence interval asks you 95% confidence interval, then the Z score on the bottom is 1.960, which is 1.96. So use bottom one. So this question, use 95% confidence interval, 95% confidence interval, 95%. Go bottom of this table, you got 1.96. When it is Z, you got 1.96. 0, you can delete that 0, 1.96. So here we use 1.96, which is this and this side, and this is 95%. In here, 95%, and this the 2 we call alpha. So this is a 5% divided by 2. This side is 2.5%. This side is 2.5%, 2 tail. And Z alpha over 2. This one is negative 1.96 on the left. And on the right is positive 1.96. So then the mean 15.6 minus 1.96 times population standard deviation 2.8 over square root of 36. The other side is plus 1.96. And use calculator, you can figure out is 14.6853. 33333, here put a bar, repeating. This side 16.514666, repeating. Rounded to 2 decimal digits. 2 decimal digits. Because here's 1 decimal digits, so we rounded it to 2 decimal digits. So 5 and 8 add 1, it's 9. And here, truncate, so it's 16.51. So this, the true population mean will be between the two numbers. And this we call 95% confidence interval. Is from 14.69 hours to 69.51 hours. There are 95% confidence that the true population mean, mu, will fall in between 14.69 hours to 16.41 hours. Use this sample mean to estimate the true population mean confidence interval, 95% confidence interval for between 14.69 hours and 16.51 hours. And question 3 is similar to question 1. The average number of mosquito caught in 64 mosquito traps. So n equals 64. Mosquito traps in a particular environment was 780 per trap. 780 is average. Average is a sample average. So put X bar. It's a sample mean. Sample average is equal 680 mosquitoes per trap. And total has 64 traps. And the standard deviation of the mosquito caught in the entire population of the trap is given 86 mosquitoes. So sigma population standard deviation is 86 mosquitoes, standard deviation. And what is, I changed to 80% confidence interval for the true population mean number of mosquitoes caught in all mosquito traps. That's population, all mosquito traps. Here only 64, and all is a lot. So confidence interval formula for the mean, population mean, this is the formula. And then X bar is the sample mean, 780 plug in, minus, so we need to figure out Z score. Now here, looking for 80% confidence interval and looking for Z score. So you go to this table, T distribution table, 80% confidence interval. On the top, say confidence interval 80%. Go down to the bottom line, Z score. Z score is 1.282. So 1.282. So here there's two sides. One is negative 1.282. The other side is positive 1.282. So is this minus 1.282. Standard deviation population given, so use Z score. 86 over sample size, square root of 64. Less than population mean, mu, less than sample mean, 780. The other side is plus 1.282 times standard deviation 86 over square root of n. N is the sample size, 64. And you can use calculator figure out and get the two number and round it 2 decimal digits. So here 8 more than 5, so round up, get 2. And this 1 less than 5, so you truncate and still 78. So that means this between the true population mean will be falling 80% of confidence of the true population mean is going to be falling between 660.22 mosquito per trap, from this to 793.78 mosquito per traps. The true population mean average, the how many mosquito traps per trap, how many mosquitoes. The population true average is falling between 766.22 to 793.78 with 80% confidence. Next question, question 4. This is looking for the sample size. Healthcare professional wishes to estimate the birth weights of infants, and how large a sample, which is n, looking for n equal what? How large a sample size must be obtained. If she desires to be, I change to 89%, 89% confidence that the true mean, population mean, is within 4 ounces, within 4 ounces. So this 4 ounces means error, E, margin error, E equal 4. 4 ounces of the sample mean. So E is this this is E, margin error, it's E. What is margin error? It's the between true mean and true mean and the given sample mean, the difference we call margin error. The difference between sample mean and the true population mean. The error is 4 ounces of the sample mean. The margin error. If she desired to be 98% confidence that the true mean is within 4 ounces of the sample mean, that means the true mean and the sample mean, the difference is we call E. Margin error is E. E is 4. The true mean, which is mu, population mean, is within 4 ounces, which is margin error is equal 4. We use E equal 4 ounces of the sample mean. Sample mean is X bar. So the true mean is within 4 ounces of the sample mean. So you do sample mean minus true population mean. The difference need to be within 4 ounces. And this we call E. E is E here given is a margin error. We call margin error is 4 errors. Assume the population, so population standard deviation, which is a sigma, is given is 10 ounces. Those are given condition. So we will use this formula, sample size formula. Sample size formula, n equal, sample size, n equal, Z alpha over 2. So here, 98% confidence. Z is what? So we look at 98% confidence interval, 98%. And go down to the bottom, Z score. Go to the bottom, and this Z score is 2.326. Z score 2.326. So Z is 2.326 times sigma, which is the standard deviation is 10 plug in. Margin error is 4 plug in. And figure out this and take square. Take square. And use calculator, you can figure out 34.81. And always round up. If here is less than 5, still round up. So sample size is 35. So it's going to be 35 infants. Estimate the birth weight of infants. So 35 weights of the infants. Question 5. A sample of 9 net working sites for a specific month has a mean. So sample mean X bar equal 25.8. And a sample of 9, so n equal 9. 9 working sites for SPIC has a mean is 25.8. And the standard deviation, which is S 4.4, sample. So S is not sigma, it's sample. Sample standard deviation is 4.4. Find the 90% confidence. I change to 90% confidence interval of the true mean. True mean. So we use the confidence interval with a t distribution. Since this one is not given, population standard deviation sigma is unknown. But sample standard deviation S is given, is known, is 4.4. So we will use T score. So here is this confidence interval. And here use T score instead of, and here standard deviation, use sample standard deviation S. So then X bar is 25.8. Sample mean minus, now this t-score, how we figure out this t-score? First of all, we have to look for the degree of freedom. Degree of freedom is n minus 1. N is 9. 9 minus 1 is 8. So you look at this t distribution. Here say 90% confidence interval. So you look at the 90% confidence interval. This one, 90% confidence. Degree of freedom is n minus 1. 9 minus 1 is 8. Degree of freedom is 8. This side is the degree of freedom is 8. And the 90% intersection is this number. 90% and the degree of freedom is 8, is this number, 1.86. So use 1.86. That's the t-score. Then S is 4.4 over standard deviation over square root of n. N is 9. The other side change to plus. And then you use calculator figure out this. So you got the true confidence interval. So the true population mean, there are 90% confidence. The true population mean of the network side is the population mean will be between 23.07 and 28.53. And that's questions. Then question 6. A survey. This is learning the proportion. A survey 1,600 adults. So n equal 1,600. Found that 36%. So this is a sample. The sample size is 1,600. So this is a sample proportion. P hat equal 36%, 0.36. Said that they would take more vacation this year than last year. And find the 99% confidence interval. So find 99% confidence interval of the true proportion. This P is true proportion of adults who said that they would travel more this year. So the true proportion P, and so we will use this formula, this confidence interval for proportion formula. So P hat, sample proportion, P hat is 0.36 minus Z score. Now this time confidence interval is 99%. So this is Z score. So you look at this confidence interval 99%. Go to the bottom looking for the Z score. This one, bottom, Z score is 2.576. So this Z is 2.576. And one side is minus, one side is plus. Then take square root. P hat is 0.36. 36% is 0.36. Now times Q hat. Q hat is 1 minus P hat. 1 minus 0.36 is 0.64. That's Q hat. 0.64 Q hat over sample size N is 1,600. And the other side just change plus. Now use calculator, you can figure out this. So the true population proportion, the true proportion, population proportion of the people want to be have more vacation this year is between 32.9% and 39.1%. You change 0.329 become 32.9%, and 0.391 become percent is 39.1%. So use this sample, 36% of with 1,600 adults. There are 36%. You estimate, you survey 1,600 adults. Find out there are 36% of 1,600 adults would have would take more vacation this year than last year, and use this to estimate a 99% confidence interval of the whole populations of adults. Was said they would travel more this year. The 99% confidence, the true proportion will be falling between 32.9% to 39.1%, with 99% confidence. Then question 7. It is believed that 36% of, so P hat is 0.36 of U.S. homes have a direct satellite television receiver. So P hat, it believes U.S. homes have a direct satellite television receiver. 36%, 0.36 is P hat. How large a sample? Looking for sample size N. How large a sample is necessary to estimate the true proportion of homes which have a direct satellite with a 95% confidence. 95% confidence, and within margin error E is 3%. So margin error 3% is 2 decimal is 0.03. In this formula, this margin error is between true proportion, which is a population proportion, and the sample P hat sample proportion, the difference within 3%. That's what we call E, margin error. And we will use this sample size formula for proportion. So N equal P hat is 0.36, Q hat is 0.64, and Z here say it's 95% confidence, and use Z score. So you look at the table, 95% confidence, 95%. Go down to the bottom. Z score is 1.96. So use Z. It's a 1.96. Over margin error given is a 0.03. Parenthesis square. Then you use calculator to figure out this one. And no matter this is what, if less than 5, still round up. Always round up. 984. So there are 984 homes. You need to estimate. You need to survey 984 sample size. How large a sample? 984 homes. It is necessary to estimate to the true proportion of the home with 95% confidence. You need to estimate 984 homes. You need to survey 984 homes. And next question, question 8, we are going to figure out the confidence interval for the variance. And question 8, find the 95% confidence interval. So given condition, confidence interval 95%. For the variance, looking for sigma square variance of the height of a maple trees. If a sample of 16 trees, so n equals 16 trees, has a standard deviation, so S, because sample 16 trees is a sample 16 trees, and has a standard deviation. So this is the sample standard deviation. So S equal 12.8 feet, 12.8 feet height. And assume the population is normally distributed. So we will use this for the variance. We will use the chi-square. This is a chi-square distribution. And we're looking for chi-square. This is a chi-square distribution. Chi-square distribution. This here is a 0 to the right of the 0. So you look at this. This to the right is a positive. To the right is a positive. They want confidence interval is question 1, 95%. And we have to find out the chi-square right, chi-square right, chi-square right, and chi-square left. And with 95% confidence. 95% confidence. That's between chi-square left and chi-square right. This area is 95% confidence. And this is a chi-square distribution for the variance. Now we have to look at the chi-square table. This is a chi-square table. We also need degree of freedom, and we need alpha. Now, what is the area for the chi-square? And the area is this side to the right of chi-square. This is the area alpha. This area. So like this 0.01. That means this area is 0.01. 0.005, that means this area is 0.05. If like 0.10, that means this area is 0.10. That area to the right of chi-square. So then we need to figure out the chi-square. Now, here is 95% confidence interval. So it's symmetry. So it is equal. So remain, you do 1 minus 0.95. 1.00 minus is going to be 0.05. Then divided by 2 is 0.025. 0.025. So this area is 0.025. This area also 0.025 because between is 95% and remain 5%. So divided by 2, this side is 2.5%, this side is 2.5%, and transfer to decimal is 0.025 and 0.025. Now, in order to get this data, and you use this number 0.025, because this chi-square table on the top, those data is to the right of chi-square. So here is a point to the right is a 0.025. On the top, 0.025 is here. Degree of freedom for this question, given n is 16. N is 16. degree of freedom is n minus 1. 16 minus 1 is 15. So you look at the degree, this table, 0.025. Degree of freedom is 15, this, 15. The intersection is this one, 27.488. So that one, so to the right, 0.025, this chi-square is 27.488. The other side we call chi-square left. You also need to figure out to the right. To the right is 0.95, add 0.025. Add together to the right of this chi-square left. To the right of chi-square left, the two numbers add together is 0.975. 0.975 according this 0.975 is here. Degree of the freedom is 15. Intersection 0.975. Degree of freedom is 15 is 6.262. So that is this data. This chi-square left is 6.262. Then we can plug into this confidence interval for the variance. N is 16 minus 1, which is 15. That's degree of freedom, times S. S is a sample, standard deviation 12.8. Plug in, square. Chi-square right. Chi-square right is 27.488. Put it in. Chi-square right. And variance less than 16 minus 1, 12.8 square. Chi-square left, 6.262. Put it in, 6.262. Plug into this confidence interval for variance formula. Then use calculator, you will figure out and round it to 2 decimal digits, round up. It's 89.1, and then this rounded truncate, and it's 392.46. So that means the variance for this with 95% confidence is going to be 89.41 fit square, chi-square, so fit square, 392.46 fit square. That's for variance. Estimate interval of variance. If one interval for standard deviation, you just take square root, this take 89.41, take square root, 392.46, take square root. Next one, a chi-square variable. Your homework can be negative, and the distribution are negatively skewed. True or false, that's your homework. Now I change it. It's chi-square. If a chi-square variable must be positive, and the distribution are positively skewed. Chi-square distribution is the graph like this. This started at 0. Is to the right. So to the right, the variable, this is x. Variable, this is a chi-square variable. And chi-square variable need to be positive. Because to the right of 0. Because square always positive. Square is positive. So the chi-square has to be positive, must be positive. And so the chi-square variable must be positive, and the distribution are positively skewed. This side, left side is a fatter, fat. The height is a fatter, and then the right side goes skinner, slim. So the height is not that high. So this we call, this side is a positive side. So it's a positively skewed. That's true. So it's a positively skewed. Skewed to the right. Chi-square variable is skewed to the like this. Chi is a positive. chi-square variable need to be positive is because square is positive. So positive and skewed to the right. So and this side is positive, so it's positively skewed. So this is true. This is true. So must be positive and positively skewed. Skewed to the right. Positively skewed means skewed to the right. To the right. So a chi-square variable, your homework can be negative. Oh, I already say any number square is positive. And the distribution are negatively skewed. Let you find out the answer